how to have different number of inputs in MATLAB functions. So that is functions in MATLAB. So I'll show you some of the live demo for this writing functions. Let's go to now what is the difference between script and function. First of all, this script, as we discussed earlier, the script is basically a series of statements which are executed in MATLAB, and function requires certain number of inputs and also outputs. So I'll just tell you how to write functions. Here we go here. For example, here is MATLAB desktop. Whenever you open MATLAB, suppose you have in your computer MATLAB installed, click on this. What opens is called MATLAB desktop. So this is the 7.5 version of MATLAB, and once you open that MATLAB desktop, you have the command window here. So suppose you take a value x is equal to 4, that will give you x is equal to 4. You can suppress the extra lines by format compact. Again, x is equal to 4 is this one. CLC is to clear the screen. You have the value of x is equal to 4. If I use sqrt x, the answer is stored in NS variable. The value is 2. Now, if I say sqrt of say minus x, that is equal to minus 4. What is that? This is complex number. This sqrt is basically inbuilt function or library function of MATLAB. Suppose I want to design a function which will give the square root of absolute value. So then I can do that by writing up my own function. So actually, if you see here, these are library functions. There are thousands of functions in MATLAB which are library functions. You can learn about them by saying help sqrt. If you say help sqrt, that will give you the description of the function sqrt. Sqrt is an inbuilt function. So help sqrt. Similarly, we discussed earlier, we have also other functions. Plot. You have many other functions like 2D plotting, 3D plotting. Here is help of sqrt. Help sqrt, what is it shows? Sqrt is the square root of the element x. Complex results are produced if x is not positive. If x is negative, the number will be just as we discussed here. X is equal to minus 4, answer is complex number. Now let me design my own function. Okay, clear the screen. I'll go to the program now. This is the M file, open the M file, new M file. I want to make my own function which will find out the square root of absolute value. Even if the input is negative, the answer will be positive. It will not be a complex number. So let's begin. I am writing a function. F1CGI function. It begins with the function word. Function, I will call it as, suppose your output is y. Output value y. And then function name abs root. I will call the function name as abs root. Abs root of x. That is the first line, abs root of x. Now this is you can write comments also here. Comment. Percentage sign is used for comment. You can see the color coding. Color comes as green. If you see percentage sign, the color becomes green. This will find the square root of absolute value. Okay. Now now what you want to do? First of all, I'll say z is equal to abs of x. X is your input, y is your output. I have taken variable z, which is a absolute value of x. ABS is again a library function. It will find the absolute value. And then what else? Output y is equal to what? Y is equal to sqrt. This is again library function, sqrt of z. So these two statements, you can use colon here if you want to suppress the output. So z is equal to absolute value of x and y is equal to sqrt of z. That means you get the answer desired by you. Now let's save the function. Pay attention to this very carefully. If we save the function here, the name of the file is same as the name of the function. Pay attention. Without that, the function will not work. This is the function name. The construction is like this: function output value equal to sign function name input value or input values. If there are more values, you can have commas. So ABS root is the name of the file. Automatically MATLAB will take the same name as the function name ABS root. Save this thing. Now you have made a function of your own. User defined function ABS root. Now you can see this thing now, the same value here. We had the value of x is equal to 4. What should I say? ABS root of, what is that? Minus x. But that will give you the answer as 2. Earlier it was my 2i, complex number. Now this will give you just a simple demonstration of how to write a function. Now one very interesting thing. Previously, when I said help of sqrt, it gave me the value how to use help. How can you write your own help? Here is very important concept. Whatever you want to write down in the help, whatever you want to display in the help line, that has to be written here. I'll show you. If you write down here, this will find this will find the square root of absolute value. Whatever you write here, okay? Whatever you write here, everything will be displayed after this first line. Okay, A, B, C, X, Y, Z, whatever you write here. That these lines will be displayed in the help line. These green lines will be displayed in the help. When I say here help, what's that? I can save the file, make sure the file is saved, and then if I say this thing, help of ABS root, that will give me, as you can see, whatever I have written below that first line is displayed as a help line. So here you can demonstrate, you can describe your function in the function construction is the following: function definition line, help line, and the function body. That is about the function. And the name of the function is same as the file name. Now let's take the more number of inputs. I'll give you a simple example about to demonstrate how MATLAB functions can take different number of inputs, different type of inputs, and the same function can do that all those tasks. So here is a simple example of that. I just discussed about this one, how to write a function. Okay, fine. This function output variables, function input. In case you don't want to have any output, remember the here function name output is missing. This is also allowed. Now let's do this thing. I want to design a function with more number of inputs. Here is the example, all of you are aware. This is what? This is conversion of Cartesian coordinate to cylindrical coordinate, right? So this is conversion of that. So x, y, z should be the input of the function and the output should be r, theta, z. So here is the function. In MATLAB I have written here. I'll open the file which is already defined here. That function is the function written here, there is convert. Convert.m is the file name. Open that file. It will open the value. This is the function. What do you see here? Function r, theta, z is the output. Because you have more number of outputs, you have to use square bracket here. And convert is the function name x, y, z. Remember, here you must use square bracket and here you must use small bracket. Now this is the same formula, square root of this Okay, as you see here in the slide, you can see here same formula r theta z tan inverse. What is the function? What is the function for tan inverse? Anybody? The function is tan, right? Tan is the function for tan inverse. So here you get here the answer. R is this square root of, and why do I use dot here?
Array multiple.
Right, absolutely right. Because without dot, it will not be able to take the array inputs. If you want array inputs, you must use dot here because the product will be array product. Element to element multiplication. I use dot for that reason. Okay, fine. So this is a save the function. Function name is convert. 3 inputs and 3 outputs. Let's see this thing. Execute it. What should I do? I have x is equal to say 2, y is equal to say 3, and z is equal to 4. 2, 3, 4 is x, y, z. I call the function convert. I'll call it as r, t, z. R, t, z are the 3 outputs. And the convert is the function convert, and x, y, and z are the 3 inputs. You get the 3 outputs, right? What happens if you call the function with, say for example, if I do not use this RTZ, what do I get here? See this carefully. If I call this with 1 without stop, when I call the function convert with 3 inputs, there are 3 outputs. When I call the function convert, with 3 inputs but output is not written here, the output goes to default variable answer, and the only first output will be transferred to answer. Right? Now let's see this thing. I just told you I have used here. What do I use? Dot product. What is the beauty of using the dot? Because let's see this thing. Now suppose I take 3 inputs, C and C. If I take x is equal to array input 1, 2, 3. 3, this is the array. Y is also an array of order 2, 4, 6, for example. And z may be, you may have a positive or negative number, whatever you may have, minus 3, 5 and 7. Now again x, y, z you have, again go back to the, call the function convert with x, y, z. Now what are the data types? 3 array inputs. Will it work? Absolutely. It will definitely work if we have provided you use the dot here. Yeah, right. But if you not use dot, it will not work. Because it will take it as matrix multiplication. This is not allowed. Now let's call this thing, got the answer. You see this is the long format. If you want to display in the short format, you can just say format short. Clear the screen. Again I'll call this thing. I already have the value of x, I have the value of x, I have the value of y, I have the value of z already stored in the workspace. In this side you see, and I just call the function convert this thing. You got the short format answer. What is the answer? R theta z corresponding to the first input. First 1, 2 and minus 3 will give you R T Z as the first inputs, first outputs. Second input 2, 4, 5, the output second and second output. And the third input 3, 6 and 7, the outputs are these 3, last 3. That is a beautiful feature of MATLAB, that it can take not only single input but also the array inputs, right? Now let's do one more thing, very interesting thing. In case of C, C++ and any other program, this is not allowed. If you want to write different types of inputs, you have to write different functions. Now one more thing, suppose if I have only, let's say, 2 values, x and y. You all know that if I just have 2 values, x and y, and I don't have z, then this you can call it as, conversion from Cartesian to polar. So here is the function. I'll ask you the question now. The question is the following. I have another function which is written in the file name as convert2. Convert2, what is this function? Now you see this carefully. Our same function convert to the name of the function. I have but here I have used two terms which are very important to understand. NRGIN. I have used this. There's one more term. NRGOUT. I have not used it here. But NRGIN is a term. NRGIN is a keyword. NRGIN is a keyword which denotes basically number of arguments in the input. Similarly, there is another word that is called NRGOUT. NRGOUT is used for number of arguments in the output. So NRGIN is number of arguments in the input. Input is here, and NRGOUT is number of arguments in the output. So you can design a function to take different number of inputs and supply different number of outputs. I'll show you how. Now in this case, x, y, z are the three inputs. Suppose I call the function convert with three inputs. What should it give? This is example. Suppose I call this with two input first. So what is that? If NRGIN is equal to 2, the condition is applied here. If NRGIN is equal to 2, that means if the input arguments are not 3 but 2 only, then I'll get only R with theta. It's like I written here, following will convert the Cartesian to polar. And else if and AND. This completes the if condition. Else if number of arguments is equal to 3, it will find out all the 3 values. This is conversion from Cartesian to cylindrical. The same function is doing both the things. If there are 2 inputs, it's doing something. If there are 3 inputs, it's doing something else. Similarly, you can also use NRGOUT. You can call the function with one output or 2 output or 3 output. Now run the function here. The function name is now convert to. Let's do this function convert to. It has a condition. If there are 2 inputs, it will do R theta, and if there are 3 inputs, it will do conversion from Cartesian to cylindrical. Let's say again run this function. X is equal to this, y is equal to this, and z is equal to this. If I use this previous command, if I call the function convert with x, y alone, will it work? No, it will not work. It will give me error because I have designed these are two functions here in the same window. Convert is only with the 3 inputs. I have not used any condition. But in convert to, I have used a condition. It can have 2 inputs as well as 3 inputs. But convert cannot have 2 inputs. It can only have the 3 inputs. Okay? Because here I have given convert x. I have only 2 inputs. This gives me error. Now let's do the same thing for the convert to. Convert to I will use here convert in place of that. But here output should be also 2 because if there are 2 inputs, there are 2 outputs. So RT is this thing, convert to, absolutely fine, it will work. This convert to, it will convert, if they have 2 inputs, it will give you R and theta. If you have 3 inputs, it will give you R, theta and Z. So that's what we learned today. The same function can do many things. The same function can take different type of inputs, single inputs, array inputs. The same function can take different number of inputs if you properly design it, and you don't have to write a different code for each function. In case of C++ Fortran, for each function, for each type of input, you have to declare the variables. You have to also, make different functions, different files. And in case of arrays, of course, it's very complex in C++ and Fortran. But here, array inputs also we just saw. You can take array inputs also, single inputs also, because every data is a MATLAB array. In case of MATLAB, there is no differentiation. All the data are taken as array data. It works quite fine. So least amount of effort is required to do the same task compared to any other program. Thank you.